Hi everyone, this video is on exercise 12 question 2. So in this question, we want to find the greatest value of the following functions. And it basically means that we need to find the stationary point of the function, but obviously the y-coordinate of the stationary point, because that gives us the greatest value of the function. So in this case, we first find, in order to find the stationary point, we first find the first derivative of the function and we set that equal to 0. So by solving the equation, we are going to get the x coordinate of the stationary point, and we just need to substitute that into the function to get the y coordinate of the stationary point. And the y coordinate of the stationary point can be the greatest value of the function or the least value of the function. Okay, so in this case, the first derivative is equal to minus 10x, and we set that equal to 0, which means x is just 0. So now this 0 is the x coordinate of the stationary point, but we want to find the greatest value of the function, so that means finding f of 0. So f of 0 is simply equal to 10. And this is the greatest value of the function. So the greatest value of the function. Okay, so that's how we can find the greatest value of the function. Now let's do part C. In part C, we will have the function 6 plus x bracket 1 minus x. So first of all, we need to have the function, in a nice form so we can differentiate that in the form, x to the power of n. So let's expand the bracket first. We are going to get 6 minus 6x plus x minus x squared, which can be simplified to minus x squared minus 5x plus 6. Right. Now the first derivative is equal to minus 2x minus 5. And we again set that equal to 0. So we have minus 2x minus 5 is equal to 0, which means minus 2x is 5 and x is minus 5 over 2. And all we need to do now is just finding f of minus 5 over 2, because that's the greatest value of the function. And that is equal to 49 over 4. So this is the greatest value of the function. Okay, that's it for this video, and thank you for watching.